deal with semi-annual compounding in bonds, because that's a little more realistic. That really kind of closes our discussion off of bonds in general. Afterwards we'll have a couple more things to do, but you know, the main bread and butter of bonds we've basically gone through. Now we have to start thinking about bonds with semi-annual coupons, because that's how it works really in real life. So I've designed a method, and this is just completely foolproof, and it works every single time. So if you follow this method, you will probably get every single question on bonds that you ever get right. And this is how it goes. Put these variables down. You know, we have a present value, a future value. Now, because things get periodic in a semi-annual, i.e. we know that on a bond you will always be quoted some type of coupon interest payment, but that coupon interest payment, let's say 10%, it will always be given to you as an APR, or a nominal interest rate. However, if it is a bond that is subject to semi-annual coupons, then it will say something like 10% semi-annual, and let's just say it's going on, you know, for 3 years. So if it's 10% semi-annual, yes, the percentage that's written on here as the coupon interest payment will be given to you as a nominal interest payment, or an APR. But if it's also giving you information about it being semi-annual, you have to do some type of conversion, and this is basically how to keep track of it. We're going to have PMT non and a PMT per, and that stands for our nominal payment. Nominal just stands for annual, for yearly, and our periodic payment. Now let's move on to N, which is, sorry, I, which, you know, is our yield to maturity, or our yield to call, and then N, which is the number of years. Now, because we're going into different frequencies of compounding, I want to introduce this new variable M, which shouldn't be so new actually, because from the earlier videos I introduced it before. The M is the number of compounding periods per year. So if this is a semi-annual bond, then M is going to be 2. We can put that in right now. Now, I over M is another variable which is important, and that is the periodic rate, because, you know, this is I, the nominal interest, the nominal interest rate divided by M. So this actually becomes the I per. And now let's scroll a little. Oops. Let's actually try and keep it on. And then NM, which I also introduced in a previous video, and that is really just the number of years multiplied by the number of periods. NM is just the total number of periods, because if there are 2 periods per year, actually, why don't we just throw these in? We know that N is 3, because it's 3 years. N is the number of years, M is the number of periods per year. 3 times 2 is 6, which makes sense, because there are 6 total periods. There are 6 semi-annual periods in 3 years. So that should make sense. Now, let's just get rid of this. What you need to do next is do a working problem to show exactly how to put these values into the calculator. It's not that difficult. Let's start off with like here, 10% semi-annual, 3 years, $1,000 face, and its present value, it's currently trading at $1,100, right? So it's trading at a $100 premium. So present value is $1,100. It's negative because that's how much you'd have to pay out as a cash outflow to get back your future value cash inflow of $1,000. Now, in the meanwhile, the PMT non, well, it's 10% of 1,000. So 10% of 1,000, you know, is 100. Now, our periodic payment, all we need to do for PMT per is we need to take the PMT non and we need to divide it by M. So over here we would be dividing $100 by, well, if it's semi-annual, then it's going to be 2. So it's going to be 50. So our periodic payment is going to be 50. Yes, $50 a year for 3 years, or $50 every 6 months for 6 periods, right? Now, the interest rate is what we're looking for, the YTM, yield to maturity. We'd like to know if we purchase this bond for $1,100 and hold on to it for 3 years, or rather 6 months, 6 periods, which is 6 semi-annual periods, then what is our rate of return? So that's what we're looking for. We have N, we have M, we don't have I over M because we don't have I, and we do have NM. So let's just star off the variables that we care about that we're going to use in order to obtain our answer. NM is important, I over M is important, PMT per is important, FV is important, and PV is important. These are our 5 variables that we care about. Now let's have a think. PMT nom. That was important because information was given to us about the bond in a nominal way. But once we had already discovered that, just for the sake of accuracy here, let's do 10% on 1,000. Right, and that equals 100. And all you need to do is just divide 100 by M by 2, and that takes us to 50. Once we've used the information, the nominal coupon payment information, we don't really need it anymore. What we do need is we need to get into periodic terms, because once we know there is semi-annual compounding going on, we want everything to be periodic. Now, of course, remember, if this was a crazy exotic bond and was doing its compounding quarterly, then M would be 4, and you would have divided this by 4 to get 25, and so on and so forth. And M would have been different because we'd had 3 years, but there would have been 4 periods per year, so this would have been 12, and so on and so forth. That's pretty logical. Now, once we get our PMT per, that becomes significant information because we want everything to be in periodic terms. Now, we don't know, we're solving for that, but once we've made this conversion from number of years into the number of periods, that becomes significant information because we want everything to be periodic. Now, when we solve this through, just remember, this is the answer that we're going to get. This has become our new N. So when you look at your calculator and the N variable, this is our new N. And this is our new I. So let's solve for this now, and the answer that it's going to compute is going to be the I over M. And you'll notice that because it's going to be a little bit too small, but then obviously afterwards we're going to multiply it by M, because I over M times M takes us back to I. It's going to take us back to here, which is the answer that we really want, because yield to maturities, even in semi-annual compounding bonds, yield to maturities are always quoted on an annual basis. They're always quoted as if they were annual. We don't want to know about the periodic yield to maturity. Yield to maturity, by definition, is the annual rate of return on the bond. So let's go ahead and throw these into the calculator. And once we've done that, you'll see that the I that it gives out is 3.145. So let's just call it 3.15. And all we need to do, if I over M is 3.15, to get back to I is multiply it by M. So 3.15 times 2 comes out to 6.3, or 6.29 if we were using the old decimal places. So 6.29. And that is the way to do that problem. And honestly, if you follow these, I think 8 steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, sorry, 9, then you will come out to the right answer every single time. And obviously, if you were given a yield to maturity, and you were asked to calculate the present value, you would do it in the very same way. Just make sure to always remember that this down here is our periodic information. This is also periodic information, and then this is nominal, and this N is nominal, and this I is nominal. So I hope that didn't make things too messy, but once we get into periodic information, that's what we really care about. We use the nominal information so we can convert it into periodic information, but once we do, that's all we care about, until, of course, we come back to yield to maturity, where we'd like to convert our periodic yield to maturity back to its real yield to maturity, just by doubling it in this case, If it was quarterly, you would multiply it by 4, because I over m times m just looks like that. So I think that's enough for today. Next time we will, I guess, do one more of these problems, the trickiest one that it could be, and then we'll speak a little bit more about other types of metrics that are used to evaluate bonds.